this short film I will present how to get shaft reinforcement. I start with DXF file import. We can choose units and optionally switch off unnecessary layers. First step is definition of region for foundation plate in which shaft will be cut. There are a few ways of contour generation. Here I define it by clicking subsequent points with automatic snapping to background points. When contour is defined, it is sufficient to switch on reinforcement checkbox to automatically get drawing with default parameters. These parameters can be later changed freely. Next step is definition of shaft. I define opening contour in the same way as for plate. Then I choose shaft as region type and I can define some parameters as shaft height, wall width, reinforcement diameter or spacing. After validation, program will automatically generate all necessary regions where different parts of reinforcement can be parameterized. Now as for plate, I select all shaft regions and switch on reinforcement checkbox. Program automatically generates all reinforcement bars and creates drawing. By default, two sections, XX and YY, are available. Parameters in each region can be easily modified. Here I change cover for edge reinforcement. Let's look in more detail at different types of reinforcement. Upper plate is reinforced with U-bars. Shaft plate is reinforced with bars at the corners and bars in the middle for X and Y direction, both in lower and upper part. Then L-bars are generated on each opening side. It is possible to complete vertical wall reinforcement by U-bars placed on the shaft top. Horizontal wall reinforcement is composed of U-bars which are overlapped respectively. As mentioned earlier, program, besides drawing, automatically creates 3D reinforcement, which can be easily visualized for verification. For clarity purposes, reinforcement in any region can be temporarily switched off. So here I switch off foundation plate reinforcement, I choose display of selected regions mode, and I can look at reinforcement associated with subsequent regions. The user can benefit from 3D reinforcement yet in another way, namely, it is possible to export it in IFC format into any BIM software. In shaft definition window, it was possible to set some parameters. However, it is also possible to make modifications when drawings are already created. If, for example, I would like to change number of bars in the middle of shaft in Y direction, I need to choose appropriate regions by selecting them. This parameter is available for multi-selection, so I change number of bars for required value. Reinforcement drawings are automatically regenerated. Summary table can be displayed anytime. It is also regenerated automatically after change of any parameter. It is possible to compress its contents by clicking Join the same bars option. Program will assign the same numbers to bars with the same geometry. Range of numerotation can be set in reinforcement description part. The last step is saving the final drawing in DXF format. For plates, drawings are generated directly on plate contour. For shafts, drawings are generated independently on the right side. It is also possible to create a few shafts drawings in one file. For verification, I open saved file in Drawings Viewer. Dimension lines for shaft are automatically added. Moreover, different parts of drawings are saved on different layers, so if necessary, it is easy to make some adjustments. Thank you for your attention.